Today we're going to talk about a reed switch. It's the unsung hero of the electrical switching world. It's a ubiquitous electrical switching device that you've probably got in your car, in your washing machine, in your burglar alarm if you have one. A reed switch is an electrical device that's used in conjunction with a magnet to switch electrical currents. It has two magnetizable blades inside. When you bring a magnet close by, the field from the magnet causes the two blades to be attracted together. They touch, and then you can pass an electrical current. Let's take a look at the kinds of magnets that are good for use with reed switches. Google magnets and you'll find a bewildering array of different types. I've put a few out here. Here's a rare earth magnet. This is a so-called neodymium iron boron magnet. These are small, powerful, relatively expensive, but if the application space is tight, you might want to choose that kind of magnet. Less expensive varieties, for example, are this ceramic magnet here, ceramic disc. Here's a very small neodymium magnet that might be appropriate for use with the CT05 switch in an application where space is tight. Here's a ceramic ring magnet, which is useful for applications like level sensing, something that we're going to cover a little further down in the presentation. And this is a plastic bonded ferrite magnet. This is the type of magnet that you see in typical refrigerator magnets. It's very, very inexpensive, but also relatively low powered. So you need a relatively large magnet made of this material to work at the same distance as a very powerful magnet like this neodymium magnet. This glass envelope version is relatively fragile. So what Coto does is to take those switches and embed them in a plastic overmolding. You can see this red plastic which acts as basically as a splint for the switch to protect it from shock and vibration. Now, Coto makes these switches in two basic sizes, the CT05, which is about 5 millimeters long, and the CT10 series, which is about 10 millimeters long. Apart from the splinting effect of the plastic, the other huge advantage of this design is that we can supply these switches in tape and reel format, which then allows them to be applied to circuit boards automatically using pick-and-place machinery. So far we've talked about switches, reed switches, and we've talked about magnets. Now let's talk briefly about putting them together. Return to my original drawing. I showed the magnet opposite the center of the switch, moving in this direction. Suppose for your application you don't want to move the magnet that way. You don't want to place the magnet this way. Your particular design requires you to move the magnet in from the side. What I'm going to do now is to illustrate some of the optimum positions with some animated videos that we're going to put up next. Look at this magnet position with the polarized axis of the magnet pointing towards the switch. In this case, there are two places where the magnet turns on the switch. The best places to operate are with the magnet pointing approximately towards the glass seals of the switches at either end of the switch. The magnet pointing at the center of the switch is not a good position in this case, since there is a null and the switch does not close. The polarity of the magnet does not matter in this configuration. Now look at how a bar magnet closes a reed switch as it slides by in parallel. You'll see, if you watch carefully, that there are three positions where the magnet closes the switch. This might not be a good idea to implement a position sensing application, for example, since a microcontroller might get confused about which closure to register. The solution here is to move a bar magnet on a line at right angles to the switch and move it towards the switch gap. Then it will only register one closure. A way of keeping the distance of a reed switch to a magnet constant but turning it off by moving a ferrous metal plate between the two. The plate blocks the field and the switch turns off. I've shown a way of controlling reed switches through a sealed intrinsic safety barrier. This is useful for programming devices like intelligent meters. Note that the switches are placed end on so that there's only one position where the switch is triggered. I show a method frequently used in commodity meters such as gas and water. By placing the reed switches correctly so that there is an on-off sequence that follows certain rules, it's possible to detect if the meter is operating forward, which is good, or backwards, which is bad, since if it's going backwards, somebody may be trying to cheat the utility company. Rare earth magnets are good for this application since it's undesirable to weigh down the pointer of the meter with a large and heavy magnet. Here's a common reed switch application. This is a reed switch level sensor. In fact, I pulled this from a humidifier at my local transfer station. What we've got here is a plastic tube containing a reed switch and a circular ring magnet embedded in a plastic float. This sits in the top of the humidifier reservoir. When the water rises to the top of the reservoir, closes the switch, and that triggers a circuit which operates the pump which empties the dehumidifier reservoir. And what I'm going to do is show you a simple animation of how this actually works in practice. Here's an animation of how it works. As the float rises, the switch turns on, possibly triggering a pump to empty the reservoir. When the liquid falls, the switch turns off. The advantage of a ring magnet in this application is that if it's chosen correctly, only one closure occurs, avoiding any ambiguity in the control circuits that the switch may be connected to. This system is also useful for brake fluid level sensors in automobile applications. In this case, the switch triggers when the fluid level is low, initiating a low brake fluid warning. Thanks for sticking with me so far. We've talked briefly about what a reed switch is, how to put it together with a magnet, and how to use the two together effectively to get the best results from applications. Really, we've just barely scratched the surface of this topic today, but if you go to the Coto website, you'll find a lot more technical information in our resource library that we publish there. You can also contact us at appsupport@cotorelay.com, and we'll be glad to try and help out with specific advice on your application. So thanks again for being with us.